Hello, welcome to Backend lecture number. I don't know. I'm going to be straight with you. I don't know which number lecture this is, but we're going to be learning about cloud technologies, specifically like AWS, and how these cloud technologies can apply to web development. So I'm going to go ahead and share my screen. So this presentation was brought to you by our sister club, Clouded California. And all of these slides were made by Clouded Cal, and I'm just going to be regurgitating these slides to you and telling you about like what it is that makes cloud so powerful. So let's move on to this. Okay, cool. So this was Cloud at California's lecture, and that is totally okay because we like to have fun around here. You know, we like to have fun around here. And if it means stealing a different club's presentation, it'd be like that sometimes. So let me go ahead and open the chat just in case there are questions. Okay, so the agenda of what we're going to learn today is first like a 10,000-foot overview of like what cloud is, different kinds of clouds, and why you would use clouds in the first place. After that, then we'll get into like what a global infrastructure is for like how AWS works, which is, by the way, the cloud service that we're going to be teaching you specifically here at WDB, what regions, AZs, and edges are, and a general overview of like general microservices. And yes, Alina, that is correct. That's how legends are built, by stealing ideas. So thank you for that. Thank you. Like, yeah, this is our total agenda. Let's go ahead and get started with what is cloud. So an analogy, let's say that you want to make really cool art, but you only own crayons and paper. So crayons are really cool, and like you could do a lot of cool stuff with it. But let's say you want to buy some really expensive watercolors in order to build out your dream portrait using watercolors. How do you do this? Well, one of the basic solutions is to just buy your own watercolors, right? So like go on Amazon.com, Google watercolors, and then buy that directly. Or if your friend already has watercolors, then you could borrow your friend's watercolors. In this specific case, cloud is solution number 2, which is borrowing someone else's watercolors. So the problems with solution 1, just to get that out of the way, is that now you own a bunch of watercolors. And if you're only doing one watercolor project, then you just wasted a lot of money for being an expensive watercolor set that you're only going to use once. And we could apply these directly into the traditional sense of computing, in terms of like servers, cloud servers, and so on and so forth, right? So moving this analogy from painting to real life is that buying your own watercolors is the same thing as buying your own servers. It is nice to have your own servers. However, it does get expensive. And if you're only using very simple server tools, or only very simple server use cases, then buying your own servers might not necessarily be the best fiscal option or the best like money option. And borrowing somebody else's watercolors is just renting storage space on the cloud. So here I have the bottom is the, oh, sorry, my speakers just switched. Also, I will share the slides. Do you want them now, or do you want me to share them like after? Because I will give the slides either way, by the way. So yes, but like from Google, cloud computing is the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or a personal computer. So that's a lot of words that I understood individually, but not all together. And basically all that's saying is that like, if you want to borrow somebody else's computer or use somebody else's compute space, that's cloud computing. If you want to use your own computer, whether that's like your own servers or just your laptop, then that is just regular computing, no cloud. Moving on from that, some terminology for cloud. There is on-premise and cloud. On-premise is basically you buy your own servers, you maintain all of your servers, and you incur all of the risks. So examples of on-premise is like your standard cloud solution. If you've taken CS61C, then the Hive machines are on-premise solution for servers. And even your own like laptop or computer or whatever you're using right now to tune into this Zoom lecture is an on-premise solution, since that is your own way of computing stuff. Whereas with cloud, it is using somebody else's servers. So Zoom technically falls under cloud, since you are using Zoom's processing power, using Zoom's own things in order to run this meeting that we're having right now. So cloud is actually very general in that sort of sense. Yeah, so the server in this case is something that not necessarily, actually it is physical, but is also something that you own yourself, right? So this laptop right here that I am like presenting things, it is technically a server because I could run computing programs on it. I could host web development software on it and serve different people all around the world just with my laptop. So that's what I mean by server in this case, something that serves or gives out information. Does that make sense? I will take that as a yes. Okay, cool, cool, cool. So moving on from that, let's go ahead and talk about the different kinds of clouds, like what I was alluding to earlier, right? So the first type of cloud is your cirrus, your cirrostratus, your cirrocumulus clouds. These are your high level clouds, right? And these deal with software as a service. So as you can see here, some examples of these very high level clouds is Microsoft Office, Gmail, and Google Docs. You don't worry about any of the implementation, you just use the damn thing, right? So this is in the very broadest definition of what cloud is, right? Using somebody else's compute power or somebody else's servers or somebody else's mailing application to do mailing yourself. You could totally build your own mailing service. You could have your own mailing website, but it's just so much easier to use Gmail. And that technically falls under cloud because you're using Google's mailing servers rather than building your own. So that technically falls under the cloud sphere. Moving on from that, we have nimbostratus, altostratus, altocumulus. These are mid-level clouds. So you're diving one layer back. So these are platforms rather than actual software. So like Heroku, Google App Engine, Elastic Beanstalk. Beanstalk. So rather than about worrying about the implementation, you don't have to worry about operating system or configurations. So by operating system, this is like making the decision between like Apple or Linux or Windows. That kind of decision you don't actually have to worry about, or how you configure your servers or how you're load balancing. Those types of things you actually don't have to worry about. All you have to worry about is what the code you make and how you deploy that code. So in terms of the web development space, we're mostly going to be in this area of clouds. We don't have to deal with operating systems. We don't have to deal with servers or any low-level stuff. We just have to deal with how are we going to deploy our web servers and how are we going to serve this information to the entire world. And this is where WDB's cloud is mostly going to be centered at. Moving from there, just because we have to talk about it, are the stratus clouds, the stratocumulus and the cumulus clouds. And these are low-level clouds. This is infrastructure as a service rather than just a platform to have everything on. So all of AWS, all of GCP, all of Azure as a whole falls under this kind of level of clouds. You have to deal with everything, but don't worry about the hardware. So you don't have to buy your own GPUs. You don't have to buy your own CPUs. AWS does that for you, but in terms of managing your operating system, managing all of your configurations and your configs, and so on and so forth is something that you sadly have to worry about now. Since AWS doesn't do that for you, you have to make the conscious decision of, oh, I need this specific GPU and this specific CPU, but I don't have to buy it myself. I could just rent it. And that's the low level kind of cloud. You will not be dealing with this level of clouds, mostly because that's too much detail that you don't have to worry about, but it does exist in case you want to get down towards the nitty gritty in terms of like what kind of file system you're using, or if you build that sort of application. So the next thing is that the not even a cloud part, like the ground, it's not even a cloud, SMH. And this is where you get into the on-premise solutions of building your own infrastructure. You literally deal with everything, including buying the servers, including buying your own laptop, and so on and so forth. And this is how everything is differentiated from the very high level clouds to what you're using on your laptop right here, right now. So yeah, this is the general gist of how everything goes. You have Gmail, Google Docs, Google or Microsoft Suite as high-level clouds. Then you have the middle clouds, which is what you're going to worry about. And then the low-level clouds, which is dealing with the operating system and so on. Ignore the U. You're not actually going to be doing all three levels. You're just going to be worried about the middle level, which is like the platform stuff. Moving on, I like to include this because this really like hammers home what the difference is. So like for software as a service, it handles everything from application all the way down to networking. And then you get the platform as a service where you deal with the application and the data, but everything else you don't deal with. And then you get to infrastructure and then on-premise, which you just have to deal with more and more stuff. And this is like a very good segmentation of like what things you're worried about at each different level of cloud technologies. So yeah, before I move on to ways to utilize cloud, does anybody have any questions? Okay, totally chill. Totally chill. Moving on. So you have different ways to utilize your cloud. And the first option is to just use a full cloud usage, right? You could use only product as a service, infrastructure as a service. And then you could use these infrastructures or platforms in order to build a software as a service from the ground up with little to no infrastructure. And this is like really popular with startups and such. And if you want to build like a very simple like software application, then this is like the best way to use the cloud, is to just go full ham up with the cloud. Next up, you have your on-premise solution only, which is you only using your own servers that you manage yourself. This is sometimes called the private cloud, since it's just your servers that you deal with your own network. And this is popular with any industry which has a lot of like sensitive data or highly regulated data. So one big example is like insurance companies. There are a lot of laws that deal with how you manage insurance data and how you manage these sorts of things. So it's a lot easier to comply with just your own servers than having a different entity, in the case of AWS or GCP, deal with that for you. So that's really popular with like insurance companies or government contractors as well. And then you have the hybrid solution, which we won't really talk about, mostly because it's kind of like a legacy type of way of dealing with cloud services. It's a combination of both on-premise and cloud. So it's really really popular with old companies like banks who have a lot of legacy servers, but want to branch out into like future things. So that is why hybrid is a solution that exists. For web dev specifically, we're going to try and aim for full cloud usage. So by building out a platform to host like our web servers, then we could use the cloud to serve these things ourselves without having to actually buy a server that we use. In fact, web dev at Berkeley's website is hosted on AWS, and most of the projects we have are hosted on AWS. So it's something that you have to deal with in terms of like how you're going to serve this data to your customers or to your users. Moving on to that, there are 6 good reasons to use cloud. And first, we're going to talk about the business or the HAAs reasons. The first HAAs reason is that you're trading capital expenses for variable expenses. So what we mean by capital expenses is like the upfront cost, right? So if you buy a server, you know exactly how much that server is going to be, and you have to pay for the server, you have to pay for the server engineers, you have to pay for the person to install the server, and you know exactly what you're going to buy. The problem with variable or with capital expenses is that if you undershoot how much you need, then you're kind of screwed, right? You just overpaid for a server for something that you don't necessarily need. So one example is like if you're trying to build a model, and this could be like a machine learning model, right? You need very powerful GPUs in order to train this model. So let's say that you bought the most expensive GPU out there, and then you finish your training in literally 1 second. If you finish your training in 1 second, that usually means that you bought something that was too overkill for your specific use case. So you just spent thousands and thousands of dollars for this GPU that you only needed to spend $200 on. And that's a very bad way of like spending your costs. In addition to that, one big thing about capital expenses is that since you don't want to fall into this issue of like overspending or underspending, you have to spend a lot of time calculating just what kind of hardware you need. And for a startup, for example, that's not something that you would necessarily want to spend your time on. You want to spend your time developing your web apps rather than figuring out what your web apps are going to run on. And it's just that trade-in in time. Also, you have these, and you trade them for variable expenses, which means you just pay as you go, right? So in terms of AWS, you know exactly what you need because your use cases never go over or never go under. So you only pay for what you use, and it's very hard to overpay. Unless you're doing something very, very wrong on AWS, you will pay exactly what you need in order to get your exact product to work. Next, you have HAAs reason number 2, which is benefit from economies at scale. So you're not the only one using the cloud, right? And servers are shared with thousands to millions of customers. And just because AWS is hosting these many servers, the cost of those servers is thus split to everybody using the cloud. So not only are you paying for these servers, all the millions of customers on AWS or GCP or whatever are also paying for these servers. So you have a lot of these unbeatable savings. Also, none of you know Raj Dasani, but he's a HAAs major, which is why he's on these slides. Moving on, like I said before, this is cost spent on hardware instead of software. So you want to spend all of your time on developing good software rather than figuring out the right hardware. In addition to that, it's not even just the cost of the servers, but the people maintaining the servers, right? So servers are expensive, but server engineers are even more expensive than that. And instead of spending your money on servers or server engineers, you could just spend your money on more software engineers to create a better product, which is more bang for your buck. Now you have your EECS reasons. So rather than thinking of just the business side, we could think of like the implementation or technical side. The first reason is similar to HAAS reason number 1, you pay as you go, which means you don't overpay for servers that you use and you don't have to worry about underestimating demand. So this goes back to the reason of like having exactly what you need rather than overpaying or underpaying for something that you don't. Moving on with EECS reason number 2, you have faster deploys of products. So now server time, or the time spent building your server, is time spent developing your software or developing your web apps, right? So on-premise requires the setup of OS, virtualization, networking, and so on and so forth, and also the cost of changing the hardware. Now, instead of doing that, you could spend your time just putting it on AWS and having AWS do all of the work. So you can deploy in literally minutes instead of hours of just swapping out your OS, swapping out your hardware, and having everything work from there. Now moving on to EECS reason number 3, we have a global deployment immediately. And handling a global infrastructure is really, really hard. You need a lot of data centers, you need a lot of servers in your data centers, and you need a lot of networking in terms of like, how are you going to address international IP addresses? Or how are you going to serve something from San Francisco to Tokyo in a very short amount of time rather than having them wait seconds? IaaS, or infrastructure as a service cloud providers, do this for you. So with companies that went global, like 30 or 40 years ago, they had to manually build up these data centers, build up these connections, and build up these links in order to deploy this web app or application for everybody around the world. And that would take literally years to do. Now, since AWS did that for you, you can go global in literally just minutes. So with a few clicks of a button or a few different kinds of like configurations, you could easily serve your web app to Tokyo, not just the United States. So any questions so far? I know that was a lot of information. All right, cool. Vibes only. Moving on. So now we're going to get into the nitty-gritty of how AWS specifically works. So where is it all running? AWS owns a lot of data centers, and in addition to that, they have extra data centers that are also rented out by Amazon for Amazon. So storage and compute is hosted in regions, and each region has availability zones and edge locations. Now, what the hell did I just say? Let's go ahead and dig deep. So first is a region, and a region is just a geographical location in the world. So for example, US West 1, US West 2 is like Northern California versus Oregon and Washington. So literally just a physical region that you define on the map. And each of these regions has availability zones, which are AZs, and edge locations. In addition to that, each region is isolated. So there is no overlap of the regions. Like once you get to a certain border, you switch from one region to the next. And that also means that there is no sharing of AZs or edges. So whatever AZ or edge that is serving you at a certain moment only serves that specific region rather than serving multiple regions. These are governed also by potentially different countries and state laws. So not every service is in every region. You don't necessarily have to worry about that, since in AWS or in web dev, we're just worried with 3 specific ones. But it's good to know in case you want to branch out into more cloud specific stuff. Moving on from that, US East is the largest region on AWS, and new services are almost always released here first. In addition to that, regions are represented by region codes. So like I said before, US East 1, US West 1, US West 2. And you could see all of these regions by peeping this cool map. So yeah, these are the locations of all the edge locations and whatever regional caches there are. Don't worry about what that is, since we'll probably have AWS do this for you, but it's just cool to know like how it functions at the back end. So in terms of availability zones now, these are data centers that are owned and operated by AWS. These are the actual data centers where storage and compute actually happens. So more is almost always equal to better. This allows for redundancies. So for example, if you're storing some data in one availability zone and the entire availability zone goes down, then you have multiple availability zones to pick up the slack just in case that one goes down. So this creates a robust solution, and it is called a multiple AZ solution. And these are fast responses between AZs. So even if one AZ goes down, the other one can pick up the slack and you won't even notice the difference. Again, you don't have to necessarily worry about dealing with a multi-AZ solution, since the things that we're going to do is going to create that for you. But it is good to know how it's going on in the back end in case you want to dig deeper into the more nitty-gritty of cloud. Moving on to that, we have edge locations, and these are very useful for fast uploads and downloads through caching. So after the first call, latency is independent of geographical location. Now, what the hell does that mean? That means that if you're trying to get data from Japan to California, it will take a very long time because you have to jump through multiple networks, multiple cloud services, and so on and so forth, just to get that data from Japan. However, after you get that data from Japan, all of the data that you got will be stored in the North America edge location, which means instead of going all the way to Japan, you just pick up the information from your North American edge location. So peep this cool chart. This just shows that after you access endpoints on a regular format, it takes a very long time. But after the first invocation, everything is cached, which means that you could keep getting that data in a very, very fast way. Moving on from that, a side note, AWS GovCloud is a thing. You don't have to ever deal with this, but this is mostly if you're working with like defense companies or the government. And it's just a very different kind of like edge location or region, just for like those very sneaky government contracts. So if you ever do boring government stuff, this exists. Any questions so far? Again, that was a lot of information, but I believe y'all can handle it. Any questions so far? No questions? That is totally okay. Let us move on. So next, some core AWS services. And first, before we dive into that, let's define what a microservice is. So what a microservice is just a focus on a single function. This small service does a small thing very, very well. This is a means to the end rather than the actual goal. So you don't develop your app on just one microservice. You develop your app on multiple microservices in order to actually make the app that you want. In addition to that, you get into piecewise development, which is simpler to deploy, simpler to delegate, simpler to architect. That just means that you could have your development team do one specific microservice and make that well, and then put everything together to make your overall architecture. And that's why it makes things simpler to deploy and simpler to delegate. In addition to that, you get into non-monolithic hardware. Also, in terms of what I mean by a service, I will get into that later. So stay tuned, friend. But yeah, in terms of like non-monolithic stuff, this separates a broad solution into just independent parts. So for example, in your monolithic like API, you deal with the users, threads, and posts yourself. Everything is built on this giant monolith, and you have to handle everything in this monolith. Whereas with a microservice, you have one specific microservice dealing with users, you have one specific microservice dealing with threads, and then you have one specific microservice dealing with posts. So this is just taking your very big application and then breaking it down to the smallest possible pieces. Also, let me blow my nose real quick. Okay. Now, this is the most core of microservices. This is by definition cloud. And this is the Elastic Compute Cloud, or EC2. These are very simply just servers that you could rent. And like I said before, these are the core of cloud services. AWS handles operating system, CPU, memory, and GPU, and then you handle the rest. This is extremely simple and yet extremely powerful. And one of our first homework, during the next cloud lesson, we're going to be going into how we can use EC2 to host those node APIs that you were building in the past 2 lessons. So you have to host those APIs somewhere, and EC2 is the very core service of how you can host that API. So that's why EC2 is like that. Next up, you have S3, which just stores stuff. There is nothing to be said. It literally just stores stuff. So instead of hosting your hard drives, just use AWS's instead. And it's really easy to control who has access to this. You could have things publicly stored versus privately stored. And you have like user level granularity. Don't worry about user level granularity. It's just something that you could do with S3. Next up, you have AWS Lambda, which is where you start getting into serverless things. So here you get into functions as a service, which is higher level up than software as a service. Here you pay for compute time, so basically how long your Lambda function runs, rather than having to actually worry about coding servers. All of the scaling, runtime, and operating system is handled by AWS, and there's a lot of key differences between Lambda versus EC2. The first is you pay for code invocation and runtime, but you don't have to handle dependencies, you don't have to handle scaling, and you don't have to handle networking permissions. Everything like that is already baked into AWS. So one of the key things that we'll be using Lambda for in WDB is, instead of building a Node script or a Node web server or a Django web server or a Flask web server to build our like requests and stuff that you learned in the previous 2 lectures, you could have Lambda do that for you and have everything integrated into the cloud. And we'll go into more detail about this in the later cloud lectures about how specifically we're going to do this, but it's the use case of how we're going to use Lambda here in the context of WDB. Moving on from that, we have SNS, Simple Notification Service. You won't necessarily use this, but it's cool to know. It just manages messages and notifications, uses a sub-pub model or a subscriber publisher, notifications to the subscriber. I like to use the YouTube example for this. So you have a YouTube channel, which is the publisher, and then you have the subscriber or the people who subscribe to this YouTube channel. Whenever an event happens, or in our YouTube case, whenever a YouTuber uploads a new YouTube video, then all of the subscribers get notified of this YouTube video. And that's basically how this pub subsystem works in SNS. And you could do very simple notifications. For example, like, oh, your EC2 server crashed. That could be the video that your YouTuber publishes. And then your subscriber could be something like a script that you built in order to rebuild the EC2 server. So that's one example of using SNS. Moving on, we have Cloudfront. And this is where the edge location caching actually like starts happening. So Cloudfront stores all of your data at edge locations, and this is how you actually get those faster reads and writes. Again, you don't have to worry about this specific kind of microservice, since we're going to be dealing with Lambda that does this already for you. But it is, again, good to know how everything functions. We have Elastic Block Store, which is kind of simple for EC2. So you could store data, and it offers persistence in your compute microservices. And this is important in that if you're trying to build or scale multiple servers up and down, then EC2 will have its own file system in each of the compute instances. But if you tear down a server, then you lose all of your data there. Everything is it's called an instance for a reason. It's instant, it's only there when you need it. Whereas with EBS, even if the instance goes away, all of your data is still there. So that's why you can attach EBS to EC2 in case you want that kind of persistent memory. Now we have kinesis, and this is the big data stuff. So if you're very interested in data science or big data, kinesis is for you. It handles real-time big data pipeline handling, ETLs and stuff. If you were there at info session number 2, I talked about how I built a web app to classify fake news. In order to build that website to classify fake news, we had to funnel in a lot of data from web scrapers and like get a lot of articles. We use AWS Kinesis for that to make our lives easier. So that's one way that we could use to populate our website. Moving on, we have SQS, which is simple queue service. This manages data shuttling and does not need to be running. This is similar to SNS, but not quite. It's not actually pub sub based. So you don't have this YouTuber actually publishing stuff. It's all dependent on whether or not something happens, so trigger based. Services have to pull from SQS and services are sent data from SNS. And there's a very big difference between decoupling and persistence versus fan out. Again, you don't have to know what those terms mean, especially in the sphere of web development. But if you want to dig deep into cloud, this is a service. Here's another big one, virtual private cloud. So if you're developing a web app for just specifically inside a company, for example, Google's intranet or Facebook's intranet rather than internet, you could use AWS VPC in order to do that for you. So it is a networking layer on top of EC2. So in case you need to build your EC2 instance for just inside your company, you could use AWS VPC to do that for you. And yes, we have Elastic Beanstalk. So Elastic Beanstalk is probably a service that you're going to get very comfortable with using. Elastic Beanstalk is very easy to launch your entire website immediately from scratch. So AWS handles capacity, load balancing, auto scaling, and health monitoring. And if you just want to deploy your website, chances are you're going to log onto Elastic Beanstalk, put your website on there, and have Elastic Beanstalk do the rest. Now you know how it's doing this, since Elastic Beanstalk is just a conglomerate of services rather than a standalone service. So what I mean by that is that Elastic Beanstalk has EC2, S3, DynamoDB, and load balancer all built in to get this one giant service. So all of the 4 things that I mentioned earlier are infrastructure as a service, whereas Elastic Beanstalk is platform as a service. And again, like I said before, we're mostly going to be dealing with platform as a service rather than those low-level stuff of how everything is functioning. Yes, now we're getting to databases, which we have not learned yet, but we will soon. AWS RDS is a relational database service, and this is your bog standard SQL database. But this time, instead of hosting it on your computer, you have it on the cloud. So here you could benefit from multi-AZ redundancies. So if you're familiar with RAID, it's kind of like that, but it's RAID on a data center level. If you don't know what RAID is, totally chill. Don't need to know that. Moving on from that, you have DynamoDB, which is Amazon's version of a NoSQL database. And this is where you have free-form data storage and you store JSONs instead of actual tabular databases. So if you want to store things in a very massive free-form JSON format, DynamoDB is the service for you. It's like a Python dictionary. You have key value storages, except the values are whole entries and whole like rows in your database. Moving on from that, this AWS API Gateway is also another very key service that you will be using in WDB if you want a very cloud-centered REST API. You're going to be connecting AWS API Gateway to AWS Lambda so that you could actually make those requests that we've been building the past 2 weeks. So this is a way to connect users to software like you've learned before. There's no actual GUI or graphical user interface, and calls and requests are made over the internet. Basically, it's an API for AWS, and you can mesh this with other services. And you could think of things like the CRUD model of like what Alex taught you of create, read, update, delete, and apply that to your own internal services rather than actually having to build out your own node server. There are a few benefits to that. For example, for building it on API Gateway rather than Node, you have full functionality and the full power and support of the cloud rather than having to deal with hosting yourself. However, you do have less flexibility, or actually, no, not less flexibility. You have to worry about a lot of different configurations, which may not make things as suitable. At the end of the day, it really depends on like what you're looking for and what you're most comfortable with. But nonetheless, here at WDB, we're going to be teaching you both ways. Any questions so far? That was a lot. So it's totally understandable if you do have questions.
This is unrelated to the specs, but just like, I know like with websites deploy onto servers, like you have to buy a license and it costs money. Like how much does all this stuff cost? Because it's quite elaborate and I'd assume.
Yeah, so in terms of costs, there is actually this, oh, let me exit since this is technically the last thing. Let me hide my floating meeting controls. There we go. So there is something actually called the AWS cost calculator, which calculates all the costs for you. And like I said before, like a lot of the things are basically as you use it versus upfront. And it really depends on your types of use cases. One of the cool things about AWS is that a lot of these are actually free. So the servers, the EC2 servers that you're going to spin up is free for students to use. All of the API Lambda functions that you will create are free, up to like 1 million requests, which you'll never be close to touching if you're just doing a very small scale thing. So that's what makes it like really beautiful, in that you have all of this global infrastructure for basically $0. Which is amazing. And then if you ever get to this point where you're building global software and global infrastructure, then you could use the AWS cost calculator to calculate that for you. So in terms of costs, AWS is very centered on the very big, like a lot of things all at once. So rather than paying per invocation, you pay per 1 million invocations. Or instead of paying per hour of your server, you pay for every 720 hours. So you're dealing with those kinds of scales if you're building things on AWS. Does that answer your question?
Ish.
Okay, yeah.
Yeah, I don't know. Okay, I guess yeah, I did answer, because like I realized like websites are like very relative. And I'm assuming like the more functions your website does, the more that people visit it, the more expensive it'll get.
Yeah, so if you want like a general cost of your website, for example, WDB's website costs 50 cents per month. And the only reason why it costs 50 cents is because there's something called Route 53, which handles all of your domain name services or like routing, which is just 50 cents per domain name. So since WDB is its own domain, it's only 50 cents. And even for like really big, really powerful sites that use like React and so on and so forth, again, that's only 50 cents per month. If you're using like an internal database, maybe 60 cents per month. But like in terms of like really small personal projects, the costs are very, very low, which is like amazing.
Nice.
Yeah, so cool stuff. Any other questions? No questions, totally chill. Also, I finished that with 12 minutes to spare, so go Bears. In terms of the next cloud lecture, which by the way will not be Monday, since I think we're teaching you Django on Monday, but whenever the next cloud lecture is, where I'm actually going to like walk you through creating your own AWS account, spinning up an EC2 server, logging into this EC2 server, and then basically putting your website into EC2 and deploying that for the world to see. So the most basic way to deploy a website on AWS is to use EC2 plus S3, EC2 to host your compute and S3 to host your code, and then connect that with a DNS service in order to broadcast to the world your beautiful website. So stay tuned for that whenever we get to Cloud 2, which is in a week. Yeah. But yeah, thank you so much for coming. I don't know if Alex has released the Django homeworks, but I'll ask him about that later. But that will be due 1 week after that lecture occurred. But like, yeah, if you have any other questions, I'm just gonna stay here for the next 12 minutes. If not, feel free to leave. It is very late and I'm very understanding. So yeah, thank you so much. Later, y'all.